And with that, I will hand things over to Rama. Thank you.
Thanks, Dan. Hi, everyone. Welcome. So as Dan said, we're going to start off with our land acknowledgement. It is with gratitude and humility that we acknowledge that we are learning, speaking, and gathering on the ancestral homelands of the Mohican people, who are the indigenous peoples of this land. Despite tremendous hardship in being forced from here, today their community resides in Wisconsin and is known as the Stockbridge-Muncie community. We pay honor and respect to their ancestors, past and present, as we commit to building a more inclusive and equitable space for all. All right, and I'm excited to welcome Judi. Judi Bogardus developed her love of honeybees watching her great uncle work with his bees as a small child. Years later, after inheriting one of his honey jars, she started her own apiary. During the past 7 years of beekeeping, she has participated in numerous citizen science projects for the honeybee, worked as an ambassador for PerfectBee Online Academy, and attended MSU for her Master Beekeepers certification. 4 years ago, after reading an article on mason bees, she started raising them as well. In her free time, she is raising various poultry, birdwatching, and exploring the outdoors with her dogs. So go ahead, Judi.
Thank you, Rama and Dan, and I'd like to welcome everyone tonight to the discussion that we're having. When Rama first presented this idea to me, I was going to keep it strictly to honeybees, but the more I thought about it, honeybees do get all the publicity already, and they're always in the news. We hear about them all the time. So I thought it might be nice to do a comparison between honeybees and one of our native mason bees. So to get started, we've identified over 20,000 bee species in the world. In the United States, we have 4,000 native bees. The smallest is the 2-millimeter solitary Perdita minima, and there are also some carpenter bees that are the size of kumquats. In New York State, they have identified over 400 bees, and they include native solitary bees such as our mason bees, leafcutters, carpenter, sweat, and digger bees. And we, of course, have our social bees, which are the bumblebees, and the imported honeybee. So tonight we're going to start with a honeybee, and we're just going to take a quick look at their life compared to the life of a mason bee, their pollination, what they provide for us, and what we can provide for them to help them in an ever-changing climate that they are living in now. So to start with the honeybee, just a quick note on the bumblebee, though. Bumblebee colonies, because they're our only other social bee that we have, their colonies are annual. So all of the workers and drones, and even the previous year queen, will naturally pass before the winter season once the colony has produced its new queens. The new queens mate, forage for food, and then they'll find a safe place to hibernate underground for the entire winter. And they do this in existing holes, such as rodent holes. And if they're covered with leaf litter and garden debris, it's even better because it helps keep the snow and rain out. So that's why you often hear about don't clean up your gardens completely. Don't move all the leaf litter. Leave it for the anything that needs to hibernate, such as the bumblebees. Honeybees, on the other hand, they overwinter as a colony with the queen and the workers. Only the drones are evicted in late fall, and the workers will literally throw them out of the hive, where they will die of either starvation or exposure. So the honeybees, when the temperatures drop below 57 degrees, they form a cluster, which is basically a ball of bees that they form in the bottom box where they have stored all of the honey and the pollen so that they can overwinter. If there's still any brood left in that box, they have to keep that cluster at 95 degrees, regardless of what our outside temperature is. If there is no brood, they keep it around 85 degrees. And the colder it gets, the tighter they cluster. The warmer it gets, the looser the cluster gets. And in order to produce this heat, they vibrate their flight muscles, and that produces the heat to keep this cluster that warm. And people will often think that they're heating the entire hive, which they're not. They're heating the cluster itself, and that's what stays warm. And they move within the cluster throughout the winter. So the bees that are on the outside will move to the inside, and the inside ones will move outside. So there's no bees continually exposed to that cold air all winter. And to take a quick look at the life cycle of the honeybee, From the time the egg is laid until they hatch out, what we're looking at here is the worker bee, and it takes her 21 days to hatch. She'll live approximately 4 to 6 weeks during the season, which is spring to fall. In the winter, they can live up to 6 months clustered in the hive. The queen will hatch out within 16 days, and she can live up to 5 years. Drones hatch out in about 24 days, and they live for a season or until they mate with the queen. So to take a closer look at our queen, the queen, of course, is the one that's producing all of the brood in the hive. She's doing all of the egg laying. She's also the one that determines whether it will be a worker or a drone, and the drones are always a virgin birth. She averages 1,500 to 2,000 eggs per day, which is about 60,000 eggs she's laying per month. This naturally slows as she ages, and it's usually noticeable around the second year, which is the year that most beekeepers will requeen their hive so that they can keep those really strong, productive hives that we need to keep the hives healthy. But she can continue to lay for up to the 5 years that she may live. When the queen reaches about 6 days old, that's when she takes her mating flight, and she'll actually take more than one mating flight. And she does this by flying to what's known as the drone congregation area, or a DCA. This is where all of the drones hang out, and it's drones that are from hives miles around hers. So she's not just mating with the drones in her hive. She will mate with 17 to 20 drones, which guarantees genetic diversity in the hive and will help keep the hive healthy. And if we look at the picture here, that loose circle of bees we see around the queen, that's known as the queen's retinue. These are the worker bees that take care of the queen. They will groom her, they will feed her. And as they're doing so, and we can see in the picture, some of them are actually touching her, they're picking up the queen's pheromones. So after they get done feeding her, they'll move throughout the hive, they'll come in contact with other bees, and they'll transfer the queen's pheromones to these other bees. That's one of the things that helps spread her pheromones throughout the hive so that everyone within the hive knows the queen is here, she is healthy, we are good. So aside from taking care of the queen, workers do all of the other work in the hive, and their work is age dependent. It's not set in stone. If for some reason a large quantity of forager bees were to pass away, the other bees can step up and become foragers. Oh, sorry about that. So from the day that they are born until the second day, they are cleaning the cells and they are warming the brood. And it's the capped brood that they are going to be warming. And then from 3 to 5 days, they will be feeding the older brood, which is any larva over 3 days old. They also will help feed the queen. From 6 to 11 days, they will be feeding the younger brood, which is the larva under 3 days old. And this is also when their wax glands become active. But it is not until they reach 12 to 17 days that they will actually start building the comb. They also help transport food, which means that as a forager comes in with a load of nectar or pollen, they will give it to these house bees. They will take it and they will store it in the hive on the honeycomb or where the pollen is being stored. They also help regulate hive temperature. And one of the really neat ways they do this is they will move, if it's getting too hot within the hive, because it's a very hot summer day, they will move outside of the hive and they will all stand in front of the hive, facing into the hive, and they'll start fanning their wings simultaneously. And this actually pulls the hot air out of the hive. And it helps keep that brood at that 95 degrees that they need to stay at in order to survive. 18 to 21 days is when they become the guard bees, both at the entrance of the hive and they patrol inside the hive. The guard bees at the entrance of the hive are there to prevent other honeybees from other colonies coming in and robbing their resources. Also, they'll work on keeping out hornets, wasps, anything that may try and get into the hive, including us. And then in the hive, they're patrolling, looking for anything that does not belong in the hive. If it's small enough for them to carry out of the hive, they will. If they cannot, they will disable it within the hive, either by stinging it, or they will propolize it to keep it sort of caged within the hive. From 25 to 45 days is when they start foraging. Foraging takes an extreme toll on the worker bee, and they do this to the end of their life. So when we consider the fact that they will travel an average of 1,600 round trips just to produce 1 ounce of honey, and their average trip is 6 miles round trip, it's a lot of flying for that one honeybee. For them to produce 2 pounds of honey would be the equivalent of flying 4 times around the earth. And also, when you consider that load of nectar that they're bringing back to the hive, it averages 50 to 85% of their body weight. All of the flying will also start to tatter the end of their wings. Similar to a bird after a long migration, you'll see the feathers start to take on that tattered look. It's the same thing with their wings over the flight, which of course is going to make flying more difficult for them. And besides the nectar, we have a great deal of other resources that they must bring into the hive. Now, an average hive is about 60,000 bees. And in a hive of 20,000, they will collect 125 pounds of pollen to feed the colony for the season. Pollen is also their main source of protein. And pollen also contains nearly all nutrients required by humans, and that's why we consume it as well. So what happens is as the bee is flying around from flower to flower and she's collecting the pollen is attracted to the hairs on the bee's body. And what she does is every once in a while, she will scrape this pollen off and she's going to mix it with a little bit of nectar, and she will store it in her pollen baskets, or what's known as the corbicula. And the little bee we see here, that yellow mass on her rear leg, is pollen stored in her pollen basket that she will be taking back to the hive. Another item that they also collect is propolis. And propolis is actually tree resin. So if you've actually seen any trees that have a hole in them and they're weeping sort of that sticky substance, that is the resin that they're collecting. And they collect this to seal up the hive. They seal up any cracks or holes in the hive, because once it is sealed up, it helps them regulate temperature. They will also use it to close the entrance more. If the entrance is open too wide for them to safely guard, they will close it up to a smaller entrance so it's easier for them to guard it. Propolis also has shown antiseptic and antibacterial qualities for the bee, and they will often line the walls of their hive with it. And it is also shown evidence of being antiseptic, anti-inflammatory, antibacterial, antioxidant, and antifungal for us as well. And that's why people often take propolis. And of course, there is the nectar that they collect. And the nectar they're collecting is 60% water, whereas the honey that we're harvesting is only 18% water. And honey, the honey contains vitamins, minerals, amino acids for us and the bees. And it's also been proven to be antiviral, antibacterial, and antifungal for us and the bees as well. And it takes 12 bees to make 1 teaspoon of honey. And on average, a forager will only produce 1/12 of a teaspoon in her lifetime. They have to visit 2 million flowers to produce 1 pound of honey. But the most expensive commodity in the hive for bees, which they are actually not bringing into the hive, but they're producing within the hive, is wax. For a bee to produce 1 pound of wax, they must consume 8 pounds of honey. So it's extremely expensive for them to make. And this is often why beekeepers, after they extract the honey from the comb, they will put that comb back in the hive so the bees do not have to make all new wax again. And they can just continue on with raising the broods, storing their honey, and it saves them a lot of work. So with all of these wonderful things that we can harvest from the hive and that the bees are using, there is always the downside to bees, which is getting stung. Unfortunately, bees quite a few years, received a very, very bad reputation because they were lumped in with yellow jackets that are the ones that are bothering us at our picnics and barbecues and basically sting people for just no reason other than you're there and they're there. Whereas a honeybee will only sting when they're defending their hive, or if for some reason you're out working in your garden and you were to squash or injure one, you would most likely get stung. Otherwise, they're only stinging you when you are a threat to the hive. Now, a queen can sting multiple times, but it's extremely rare to be stung by a queen because she is always within the hive. And also, it is the worker bee's job to defend the queen. That is what they're there for. They are there defending the hive for her. A worker bee, on the other hand, can only sting once because they have a barbed stinger. So when they sting you, the stinger and the venom sac is ripped out of their body and it stays in your skin. When they sting you, they release an alarm pheromone, so the other bees within the colony knows that there is a threat that everyone must attend to. And that pheromone actually smells like bananas. So when they sting you, and now you have the stinger and the venom sac in your skin, that venom sac will continue to pump venom into your body. So the best thing you can do is fingernail or something, scrape it out as quickly as possible so that you get the least amount of venom in your body. On average, there's 150 microliters of venom per sting. If you were to be stung, per pound of body weight, it is lethal whether you are allergic to bees or not. And that's why quite often you hear stories of very small dogs or something dying from bee stings, because they're, of course, it's easier for them to get stung enough to kill them when you have a hive of 60,000 bees. The drones do not sting. Mason bees can sting you, but it's very, very rare that they do. They're extremely docile bee. They have no hives to protect. If you were to squash or injure them, you may get stung, but it's basically the same as a mosquito bite, and you do not have this localized reaction because there is no venom in their sting. So now to look at the mason bees, here in America, we have 130 species of mason bees, and they range in color from blue-black to brown to a metallic green-blue. Mason bee females' average lifespan is only 6 to 8 weeks. And of course, all females are the queens and they are doing all of the work. So when they are collecting pollen, they do not have pollen baskets to bring it back to the holes where they are nesting. They are bringing back the pollen on their bodies. They'll scrape it off their body and they'll mix it with a little bit of nectar and saliva and they'll pack it into the hole. They'll lay the egg on top. This is what is going to feed their larva, whereas the honeybee has the worker bees to feed the larva as it grows. The pollen, the nectar that the mason bee puts into the hole is all that is going to feed that larva. And it takes them about 25 to 30 trips to make this like pea-sized ball of pollen that's needed to feed the larva as it grows. They only produce one brood per year, and they can have a second generation hatch out and go through this whole cycle again. But once this mason bee is done laying all of her eggs, she will pass as well. She'll lay approximately 30 eggs, and that fills up about 7 holes. And although mason bees are solitary bees, they are not antisocial. They actually prefer to nest with other solitary bees, such as leafcutters or other mason bees. And this is a cutaway of mason bee holes and what it looks like. You can see the pollen she's packed in there, and this is the larva, and they're in different stages, so some have consumed more pollen than others. The holes that mason bees nest in are 8 millimeters, which is the size of a number 2 pencil. So they put in the pollen ball, they put in the egg, and then the brown that we see separating the egg chambers is mud that they use to separate the egg chambers, and they also use this to cap the hole once they are done filling all of the eggs. The last egg laid in the hole is always a male. And it used to be thought that the last one was a male because males were expendable. So if a bird was to start pulling the larva out to eat it, they're pulling out the male and not the female. When in truth, the last one laid is the male, so that he is the first one that hatches out, and he is ready to mate with the queen or the females as they hatch out. The female mason bees will also determine the sex of the egg as they lay it. The last larval stage will spin a cocoon. This will develop into a pupa and then an adult by late September. They will overwinter in the cocoons as adults, and they can actually overwinter as far north as southern Canada. But it is best for us to actually harvest them here because our springs can be very, very unpredictable. So here we see a mason bee that's putting the final touch on her mud capping on her reed. And these reeds are what we would use if we want to raise mason bees. And this is, the person is holding mason bee cocoons after they've been harvested. So what we would do is the reeds are removed in late summer when they're actually still in the larval stage, and you store them in a bee bag, which helps prevent wasps or ants or anything getting into there, getting through that mud, because they will lay their eggs alongside the bees, and their larvae will actually feed off of the bees and kill them. So you put them into a bee bag, which you can purchase at any mason bee supply warehouse, or as I learned, you can actually use pantyhose because they're the same fine mesh that the bee bags are. So then late September, they are adults. And in mid-October or a little bit later, you will harvest the cocoons. And we do that by splitting these reeds and taking the cocoons out. And you're actually going to clean the cocoons so that you can store them in the refrigerator. These cocoons are a very hard shell. So you can actually wash them in water with a little bit of bleach to remove any diseases that may be on them. You dry them out very well. You also want to clean out the housing so that there's no diseases or any mites or anything that are still left in there, and you're ready for the next season. This decreases the chances of next year's bees dying from any residual diseases that are left in that housing. Then the cocoons are stored in what's called a bee safe, which helps control the humidity for the cocoons so they're not too wet and they mold, or they're not too dry and they'll die. But the best part about this is it allows you to release the bees when you start seeing your fruit trees and berries start to bud and bloom. This year I tried a little experiment, and I left some of my mason bees out to make it through the winter on their own. And I'm sure everybody remembers it was very early April, I think the first week of April or the last week of March, we hit that 1 week of 85-degree temperatures. All of those mason bees that were outside hatched. There was nothing blooming. They all died. So the ones I had in the refrigerator, I was able to watch my apple trees to see when they started budding, and then I can release them so that they hatch when there is food for them. Here we have, this is a little mason bee that's hatching out of her cocoon. This is actually a red European mason bee. So they start hatching very quickly. Once the spring temperatures are a constant 55 degrees during the day, they will hatch out. And as I had mentioned, it's first the males and then the females. The males hang around waiting for the females to hatch. They will mate with them and they will die shortly after. As soon as the females are mated, they will start looking for housing, nectar, mud, and pollen. They look for these where they hatched because they prefer to raise their own brood near their own hatch site. And if they do not find just one of these resources that they need, they will go off and look for a place where they find all four, and your mason bees will be gone. So you need to make sure that you have all of this available for them if you're interested in raising them. Because April can be very crazy with its weather. They will shelter in the holes during cold spells if we have any snow, and they will shelter in the holes overnight. So they're actually very hardy as long as they have a place to shelter, and they will be back out flying during the day. So if we wanted to raise either honeybees or mason bees to help them out, Honeybees, of course, the most common hives to raise them in is the Langstroth, and they come in 8 and 10 frame hives. The boxes on the bottom are what's known as the deep box or the brood box. They're the largest box on the hive. Above them are the mediums or the honey supers, where the honey is stored, and these are also the boxes that the beekeeper will pull to harvest the honey. The boxes are extremely heavy, and you learn different techniques to moving these boxes as you're doing inspections and as you're harvesting honey. And some beekeepers will use mediums for all of the boxes in their hives just because of the weight. So if they're using all mediums, a medium full of bees, brood, wax, honey, and the wooden frames weighs about 65 pounds. A deep full of all the same will weigh 100 pounds. So it is very heavy. When you place your hives, you need to have a location that gets morning sun to help warm them up, but they need midday shade so that it helps them regulate that hive temperature, because you don't want them getting too hot. But during the winter, it's nice to have full sun all day long, because that helps keep them warm. So a lot of beekeepers will either put up some form of shade cloth above their hives, or they will often locate them under deciduous trees so that they have the shade during the summer, but during the winter, they have all of that sun. We also like to provide wind protection for them. Some beekeepers will put wind protection up before the start of the winter, or they may have a natural form of wind protection, such as a berm or something. But you don't want to put them in a spot, say, in a corner between a house or a garage where they don't have airflow, because airflow is also critical to helping them regulate their hive temperature, and it also helps control the moisture level during the winter, because excess moisture in a hive during the winter will actually kill the bees faster than anything else can. So with the hives, we can get very creative, as we see the one person here has done with their hives. Skeps, which are the hives on the right, are no longer allowed in most areas. They're a very antiquated form of beekeeping, and you actually have to destroy the entire hive to harvest the honey, which kills the colonies. And on the bottom left is what's known as a top bar hive. And this one has the lid of it open. So what we're actually looking at is the tops of the frames where the brood and the honey is stored. And where we see all the bees on the front, that is the entrance to the hive, and that is where the brood is. And then as you move further back is where the frames of honey is stored. So this way, with these, you're only lifting individual frames to do inspections and also to harvest the honey. So this is wonderful for anyone that has any type of physical disabilities, because they don't have the heavy lifting of your standard Langstroth hive. And another nice part of the top bar is they can be built at a height that makes them wheelchair accessible. So basically, they can be used by anyone, and it gives anyone the opportunity to try beekeeping. Now, comparing that to mason bees, mason bees are nice, light little houses that are similar to a birdhouse. But I thought that insect hotel was a really cute idea if you're very creative, and you can build that, because they will nest with butterflies, other type of pollinators. So you could put something like this up in your yard to attract a lot of pollinators. But the most common housing is what we see across the top, with the reeds in it, because this can be cleaned out. And their housing also needs to have a southeast facing the sun in the early morning, because they'd like to be warmed up before they start flying. They also need the shade midday from the hot sun, and they need it even more than honeybees, because unlike honeybees, they have no way of cooling that brood. So if they're baking in the sun, the larva is literally baking within those reeds. They need smooth mud for the egg chambers and to cap the reeds. And I always tell people the mud is similar to what a potter would use when they're making pottery. You want that consistency. The overhangs that we see here on these help keep the rain out of the reeds, and it's very, very beneficial to them as well. And the one on the right has a bird guard on it. You can buy the bird guards with the bee houses, or you can make your own, as this one, just by getting hardware cloth and stapling it onto the mason bee house. And you want to have it about a ½ inch away from the front of the reeds so that the birds cannot stick their beaks in there and pull the larva out. This is an up-close view. On the left, we have the mason bees, and you can see how they've capped off a lot of those reeds. You can also see some of them have smaller holes, which means that they have hatched out and they are now starting a second generation of mason bees for the season. On the right is leaf cutters. Leaf cutters do not use mud. They actually use leaves to create their egg chambers. And they like a leaf that has the same pliability of a rose leaf. So you can tell which one it is by looking at the ends, whether you see the mud or the green of the leaf cutter bees. And if you don't see the green, but you see what looks like a brown dried up leaf, that's just a late season leaf cutter bee. So when they're pollinating, when you think about the honeybee, they're working in a dark hive all of the time. So in order to recruit more bees to help them pollinate, because they pollinate in large groups, the forager will return to the hive to recruit more foragers. And they do this by entering into the hive, and the comb at the entrance of the hive is what's known as the dance floor. And they will do a waggle dance. And as we see in these 3 pictures, these are 3 different types of waggle dances that they do. And the direction that they're moving, the number of times that they waggle their little heinies during the waggle dance, and they move around their circles, this conveys the direction and the distance to the source using the hive location related to the sun. They can also do this on cloudy days. So it doesn't matter if the sun is actually full shining or you have cloud cover. And as they're doing their dance, it creates a vibration on the comb, which attracts other foragers. They sometimes will bring back samples if they found something very, very good, so that they can say to the other bees, hey, look, I found an awesome, awesome pollen source or an awesome nectar source, to get more bees to follow them. And when we compare them to the mason bees, although mason bees, which is the little bee on the right that's completely covered in pollen, mason bees, they actually have a 95% pollination rate of the flowers they land on versus a honeybee's 5%. And this happens because a mason bee sort of belly flops onto the flowers, and that completely covers their scopa or their hairs in pollen. And because they don't have the pollen baskets to store it in, as they move from flower to flower, pollen will fall off of them onto the other flowers they visit and help with their pollination. Whereas honeybees are collecting from the hive, so they're constantly scraping that off, storing it in their pollen baskets, because it's vital for them to get that back to the hive. Mason bees also are generally the first of the season to fly. They will fly in cooler temperatures, and they'll fly in a light rain. So they're gathering pollen and nectar earlier. They start in early April and they go through June. So they're great for our spring blooms, our fruit trees, our berry bushes. And then about midsummer, the leaf cutters will take over because they prefer an 80-degree temperature. So they're good for our later season gardens and summer flowers. And both mason bees and leaf cutters fly 2 times longer per day and in less ideal weather than the honeybees, which makes them the better pollinator. Honeybees also, they tend to pollinate in groups, and they will stick to one plant, as we see in this picture, and they will stick to it until they've used up all of the resources on that plant, whether it's nectar or pollen. Whereas mason bees, they are pollinating by themselves, and they wander as they pollinate. So they may hit 2 or 3 flowers on this tree, and then they move to the next one. They may move back to that one. They're just very free spirits out there, landing on any flower that they choose. The other thing is mason bees only pollinate within 300 feet of wherever they're raising their brood, whereas honeybees will fly up to 5 miles to find resources for their hives. This creates a problem with pesticides because for most of us, we can control what we do in that 300-foot radius of our yards, and we can control how we raise our plants. We're not spraying any pesticides, any chemicals, whereas that 5 miles we have no control over. And so honeybees will be bringing back a lot of pesticides to the hive. It is then being fed to the brood. They are eating it, and this is causing a lot of the problems with the honeybees that we are seeing now. They both do provide very valuable pollination services for us. As we all know, honeybees are used widely in almond orchards. They're used for blueberries. They're just used for so many of our crops. They also are great for native plants. Mason bees are fantastic with native plants because they have literally been raised with them since the beginning of time. And they both provide food for many species besides just us. They are now testing mason bees in orchards and on farms to help fill in where the honeybees are having problems. And if, heaven forbid, they need to take over for honeybees, they're hoping to figure out how to do this with mason bees. So with all of these wonderful pollination services we have from both types of bees and the resources we get from honeybees, such as the honey and the pollen, they themselves are facing so many challenges. Honeybees are facing all of these pests and predators. Now, within the hive, they have to deal with mites, wax moths, and small hive beetles. Outside of the hive, they have predators such as the yellow jackets, dragonflies, skunks, bears. A bear will demolish a hive in seconds. But the worst is humans. We are having the biggest impact on honeybees. So with all of this, they also have to deal with all of these diseases and viruses. Quite a few of these viruses are carried by varroa mites. The varroa mites are feeding off of the bees, and that's how they spread these viruses to the bees. And they spread it from colony to colony as well. And this is what's causing so many problems and why we are trying to find so many ways to control the varroa mite and also to treat or prevent the viruses and diseases that honeybees are now facing, and it's causing a lot of the colony collapse that we see. Mason bees, on the other hand, have a much smaller list of pests and predators that they are dealing with. The Houdini fly and the parasitic wasps are the ones that I were mentioning that actually lay their eggs within the cocoons, and their larvae will feed off of the mason bee larva. And with all of this, that they are dealing with, the actual worst threat to them, aside from varroa mites for the honeybees, is monoculture. And it is what we are creating in the environment as we try and not only house an ever-growing population, and we are taking away a lot of the native plants, wildflowers and everything to feed all of the people on Earth. We are now putting in acres and acres of single crops. Also, we are also spraying them with pesticides, herbicides, fungicides, because a farmer, of course, cannot afford to lose an entire crop. This is what they are living off of. But it is creating the problem for the honeybees versus these, acres and acres of wildflowers that we used to have, prairies and meadows that all of our pollinators would feed off of. And part of the problem with the monoculture also is honeybees or any type of pollinator, actually, just like us, needs this diversity to feed off of. Just as you or I could not live on just an orange alone or just a hamburger alone every day because we're not getting all the vitamins and minerals and everything that we need, pollinators also need this diversity in their diet. So as we look at all of this, and let's say we decide that we want to raise honeybees to help them, this is what is required to raise our honeybees. Everything under the 10 frames that we need, you can be purchased as a beginner hive kit. And in 2022, that hive kit would cost you about $480. The other equipment, I wouldn't dare price out because it's very dependent on what you want to buy. You can go with the basics or you can get very fancy with things. The only thing I will say is a jacket with a veil. Basically, the bottom line is about $95. If you wanted to go with a full suit and a veil, they start at about $170, and they can go up into the hundreds of dollars. And of course, you need your bees. And there's two options that most people go with. One is a nuke, and a nuke is basically a mini hive. And that is 3 to 5 frames that have the honey, the pollen, the nectar, the bees, the queens. Everything is right there for you and for your bees. And you take the frames out, you put it in your new hives, and the bees are ready to go. They're set. They just continue on building their colony. The other option is a package, and a package is just literally 3 pounds of bees and a queen, nothing else. So when you put that into your new hive, they are starting from ground zero. They have to build the comb, they have to find their resources, they have to start storing the pollen and nectar, they have to start, the queen has to start laying the brood. So it takes them a much longer time to start up from a package. Last year, nukes averaged about $200 to $270, whereas a package was $155 to $180. There, people will argue both, which one is better and which one is better for a new beekeeper. And I think it just depends on what the new beekeeper really wants to do. And the best thing is to look into both to decide which you would prefer to do. And then bees also require all of this maintenance during the season to keep them strong and healthy so that your hives go into winter healthy. They have to go into winter healthy if they're going to survive. That is just absolutely critical with them. Whereas mason bees are a much shorter list that we have for them. If you want to raise mason bees, you could purchase 20 cocoons for $35. And those 20 cocoons will pollinate 200 square feet. For a quarter of an acre, it would take about 100 cocoons. You can buy the mason bee house as a kit with 35 reeds for mason bees and 35 reeds for leaf cutter bees. That's about $70, and that would allow you to use that housing through the entire season. And of course, you would need to buy more reeds for the next season because the ones you have now, you're going to be splitting. You can get 250 for about $64. Your bee guard bag that I had mentioned, they're about $6. And the humidity trays, which are those little black trays you see up at the top, where we're going to be storing our cocoons in the refrigerator, they are about $10. So as you're thinking about, do I want to raise them? Do I just want to help them? What do I want to do with them? We are entering the best time of year to think about this. Now, as we're going into winter, the bees are getting ready to hibernate. They are not going to be needing any maintenance from us. So it's the best time where we can take our time to learn about all the bees, do our research, decide what we want to do, and read. You can never read enough about honeybees. They're always coming out with new information. There's new research all the time. And there's so many books and so many resources out there for honeybees. There is not as much for mason bees, but there's some excellent online sites for mason bees where you can actually watch webinars and such to learn about them. It's also a great time to join a club because it's always nice having that firsthand account of raising bees, and perhaps you can find a mentor to help you if you decide to do honeybees. If you decide you don't want to do either, you can maybe plan to work with pollinators in general. It's a great time to purchase your equipment so you have it ready for spring and you're familiar with all of it. And if you're going to buy bees, January, February at the latest is when you need to reserve your bees. Most honeybees are sold out by February. Mason bees, the latest I would push it is March because they're actually hatching out in April. So you want to get them soon enough so you have them at your site to hatch out. And if you decide, I don't want to raise bees at all, I don't want to get involved in this, I just want to put in a pollinator garden. Well, now is also the perfect time to sit down with that cup of hot cocoa or tea or whatever your drink of choice is and pull out the seed catalogs, start looking through them, start finding native plants to put in. The native plants will do better at surviving without any chemicals or anything. Whether you want to go with seeds or you're like me and you don't have the patience for seeds and you just put in the plants, this is a great time to decide what you want to do. So this is just a basic overview of everything we talked about. And if there's any questions and we still have time, we can do those.
We do. We have about 10 minutes, just under 10 minutes. So we do have one question in the chat. So if you have questions, please type them up in the chat. I'll read them out for Judi. So our first question is, how does a beekeeper clean the honeycomb so they can reuse it?
If you're harvesting honey, most beekeepers that have been doing this for a while will use an extractor, and that works by centrifugal force to actually pull the honey out of the comb. And as it does that, it'll hit the side of the tank, it drips down the tank, and there's a valve at the bottom that you open to actually allow the honey to drain out so that you can then jar it up. If you don't have a way to get to a lot of clubs will loan extractors to club members, or perhaps you know another fellow beekeeper that if you help them harvest their honey, they'll let you use their extractor for your honey. The other method is what they call the crush method, and then you're literally crushing up the honeycomb, and it is not reusable because it is just being destroyed to extract the honey from it. Extractors, they can be very pricey. You can start with a hand cranked model, which is around $150, all the way up into thousands of dollars for extractors. There's also some online sites that show you how to build an extractor out of a 5-gallon plastic bucket.
Well, while we're waiting for questions, I have a question, so I'm just gonna ask it. So you talked a little bit about how bees and pollinators need diversity, but I think when most of us like go to the store, you'll see honey that's marketed as like, you know, whatever plant honey. So is that like not real? Or is it like, is there a way to ensure that they're only getting their honey from one kind of plant or flower? Or they're like only pollinating one kind of flower?
There definitely is. If a good example is the honeybees that are pollinating almond orchards. The almond orchards are so huge, they take up the space that they would pollinate. And there are also some beekeepers that are able to put their honeybees on a farm that raises nothing but buckwheat, and that's where we get the buckwheat honey, or nothing but clover, so that they're able to get the clover. But most smaller, such as myself, which are considered a hobby beekeeper, it's just what we would refer to as a wildflower honey, because we cannot control what they're pulling the nectar from. So it's a very diverse, but sometimes you can tell what they're pulling from. Like this time of year, one of their greatest sources of nectar is goldenrod. And goldenrod, believe it or not, smells like sweat socks. It's not a pleasant smell, but it does actually make a very decent honey to use. And in the spring, the honey tends to be much lighter. And as we go through the season, it will get darker.
Well, thank you. All right, we have 2 other questions in the chat. So first, how long does it take a mason bee to hatch? Great sequence of the hatch in your slide.
Mason bees, when you put them out, they will literally hatch within 48 hours if you have that consistent 55 degrees, whereas a leaf cutter, they can take up to 23 days to hatch. You can put them out at about 75 degrees and they will take 23 days to hatch, but the warmer it is, the quicker they will hatch.
And can you talk a little about why we would harvest mason bee larvae every year instead of letting them stay in housing?
The only reason we will in this area, because our springs are very unpredictable. So you can leave them in the housing. That is definitely not a problem. You can leave them in the housing and let them hatch out naturally. But this year I did try it with some of my mason bees, and the ones that I left out to hatch naturally, I lost all of them because we got very, very warm the first week of April, but there were no plants blooming yet. So there was nothing for them to feed on. So they all naturally passed away. The other reason why you may want to harvest them is because you really do need to clean out that housing to help keep that housing clean, so the next year's mason bees have clean housing to start with, and it's not already infected with, say, chalk brood, which will kill your brood. That is also why we used to have the old wooden blocks that they would drill the holes in for the mason bees to nest in. You would get one season of bees out of that, and then the second season, some of the holes may produce mason bees, but most of them would either die within the hole, or they were so filled with spiders and mites and everything that the mason bees just wouldn't nest in them. So it just helps them if you keep everything clean and you do harvest them and you release them when you see your plants actually starting to bud and bloom.
Okay, so follow up. To confirm, the mason bees are for plant pollination only, as opposed to honeybees who create edible honey for humans.
Absolutely. The only thing that we as humans benefit from mason bees is their pollination services. They are excellent for native plants because they have, for millennia, they and native plants have evolved. The honeybees, they do provide the pollination, but we also do get the honey from them, we get pollen from them, we get propolis from them, so we get a lot more from them. But the downside is they are also a lot more work and a lot more money. So you have to weigh the pros and cons of both, and what you know, how much money do you want to invest in your bees? How much time do you have to invest in your bees? Because honeybees do take a lot more time during the season to take care of them, where mason bees don't. But they're both excellent to try.
All right, we'll give it like another minute to see if any more questions filter through.
And if anybody's looking for any resources or anything, and if Dan doesn't mind, if they could let you or Rama know, and I'd be more than happy to get back to them with some of the resources that I use.
Is it recommended to raise both types of bees within the same area?
Some people argue that no, it's not a good idea, but most people I know have successfully raised both. I do myself, because mason bees are sticking within that 300 feet, whereas honeybees are traveling much further to find their resources. And to be honest with you, the only difference I ever noticed is when I cut back on the number of honeybee hives I have, my bumblebees increased. Whereas when I had the largest quantity of hives, I would see a handful of bumblebees here and there throughout the summer. Once I cut back to just the few hives I have now, I literally have dozens and dozens of bumblebees throughout my yard all season. That's the only difference I've noticed. I have not noticed mason bees and the honeybees affecting each other.
Okay, and I think we'll do maybe one last question. When one takes the cocoons or larvae out of the fridge from overwintering, where and how do you put them outdoors?
What I do is I do not fill the housing completely with the reeds. So I leave a little bit of space at the top, and I take that little humidity, take the cover off of it, and just slide that in on top of the reeds. And they will just hatch out of the cocoons and fly out of there. And then once they've all hatched, just every once in a while, just pull it out a little bit, take a check. And once they've all hatched out, because you'll see all the cocoons are all broken up, take the humidity out, and you can fill more reeds in there. You can put more mason bee reeds in there, or you could put more leaf cutter bees in there, or the leaf cutter reeds in there, so that you have that for them later in the season.
All right. Well, we're at 8 o'clock now. So thank you everyone for being here. And thank you, Judi, so much for your talk and for teaching us about honeybees and mason bees.
Thank you, and thank you, everyone. I had a very good time speaking with everyone.